Dear friends, in this video, I will be discussing an interesting problem that involves backward recursion algorithm. I'm sure you will enjoy this particular algorithm that I'm going to illustrate with a puzzle. Backward recursion means you are reaching the solution from the last stage, and then from the last stage to the first stage where you are looking at the final solution. In other words, you are proceeding backwards, from backwards to forward. Mango puzzle. 3 friends went to a mango garden to pluck best quality mangoes. They plucked as many as they can. It became dark. They decided to stay overnight. The plucked mangoes were put in a gunny bag and closed. In the midnight, the first friend got up, opened the gunny bag, ate one mango. From the remaining, he stole 1/3 and kept it somewhere. In other words, he first ate one mango. After eating, he stole 1/3 and kept it somewhere. The second friend also did the same thing, ate one mango. From the remaining, he also stole 1/3 and kept it somewhere. The third friend also did the same, opened the gunny bag, ate one mango. From the remaining, he stole 1/3 and kept it somewhere. In the morning, when the friends opened the gunny bag, among the remaining mangoes, they found one rotten mango which they threw away. Now, if the mangoes were equally divided among the 3 friends, how many mangoes were plucked in the beginning? You solve for the minimum number of mangoes that should have been plucked, as the problem will have many solutions. So, you will have to find out the first solution, and then the next solution, then the next, etc. How do you solve this problem? In the end, when the mangoes were shared equally after throwing the rotten mango, that means we are assuming they are integers and you do not have a fraction. Each person got integer number of mangoes. And therefore, in the beginning also, they should have plucked only integer number of mangoes. No fraction is allowed as sharing. We will assume that. So we need an integer solution. So now let's look at the algorithm. We start backward recursion from the final stage. Let x is equal to number of mangoes shared by each friend in the end after the rotten mango was thrown away. In other words, each friend got x mangoes. Therefore, total mangoes in the final stage is 3 into x plus 1, including the rotten mango. After throwing the rotten mango, this 3x was shared as x among the 3 friends. So total number of mangoes is 3x plus 1 in the final stage. Now, the previous stage to the final stage is the third friend stage. In the third friend stage, since the third friend ate one mango and then stole 1/3, the remaining mangoes must have been 2/3. And therefore, it is backward recursion and therefore we multiply this 3x plus 1 with 3/2 and then add 1, which would have been the total number of mangoes before the friend ate that one mango. So it is 3/2 into 3x plus 1, which on simplification gives you 9x upon 2 plus 3/2 plus 1. Now, move to the second stage or the second friend stage. This 9x upon 2 plus 3/2 plus 1 must have been the mangoes that were remaining after the second friend ate that one mango. So you multiply this by 3 by 2 and then add 1. So 3 by 2 into 9x upon 2 plus 3 by 2 plus 1 within brackets, you multiply that, you get 27x upon 4 plus 9 by 4 plus 3 by 2 when I multiply the entire expression by 3 by 2. This is what you get. Plus 1 I add because the second friend also ate one mango before stealing 1/3. Now let's move to the second stage, from the second stage to the first stage. The first friend stage, this expression here must be first multiplied by 3 by 2, then add 1, which is the one mango the first friend ate before stealing 1/3, and therefore this expression I multiply by 3 by 2 and then add 1 as before. So when I do that, 3 by 2 into 27x upon 4 plus 9 by 4 plus 3 by 2, I get 81x upon 8 plus 27 upon 8 plus 9 upon 4 plus 1 I'm adding here plus 3 by 2 plus 1. So multiply this by 3 by 2, you get 81x upon 8. This you multiply by 3 by 2, you get 27 upon 8. This you multiply by 3 by 2, you get 9 upon 4. This you multiply by 3 by 2, you get 3 by 2 plus 1, the friend ate, and then only he stole 1/3. Therefore, this is the number of mangoes that should have been plucked. So upon simplification, the mangoes plucked will be 81x plus 27 plus 18 plus 12 plus 8 divided by 8, taking 8 as the LCM, you get a beautiful expression 81x plus 65 upon 8. That I can simplify as 81x by 8 as 10x plus x plus 65 divided by 8. Are you getting this logic? Now, what I'm doing here is 10x I'm retaining plus x plus 65 divided by 8. So when I put a number for x, let's say x is equal to 2, this will be 20, but x plus 65 by 8 will not be an integer. Therefore, the first integer for x plus 65 by 8 must be 7, because 72 by 8 is 9. Less than 7, there is no solution. So when I put x is equal to 7, I get the first solution as 10 into 7 plus 72 by 8, which is 9. So 79 as the number of mangoes plucked. This is the first solution, the minimum number of mangoes plucked. Now the next one is, after 72, this expression has to be 80 for it to be an integer. So x is equal to 15 gives me 150 plus 10, 160 as the next solution. And then 88, which means x is 23, 88 by 8 is an integer. So when I put x is equal to 23, I get a solution 241 as the next solution. In other words, the number of mangoes shared among the friends is 7 each in the first case, 15 each in the second case, 23 each in the third case, etc. The number of mangoes plucked, which is asked in the problem, the minimum is 79, then it is 160, then it is 241, and then I can make it as 96, which is equal to 322. And therefore, what happens is, in other words, when I put x is equal to 31, it is 310 plus the additional value, which I have to add 82. So it will be 322. You can check that. For example, I put x is equal to 31. 96 by 8 is 12. 31 when I put it is 310. 310 plus 12 is 322. and therefore it moves on and on. The solution is a series which starts with 79, the minimum, then 160, then 241, then 322, etc. An infinite arithmetic progression with 81 as the common difference. And ladies and gentlemen, I hope you have enjoyed the solution. This is a classic puzzle which involves backward recursion. Of course, you can do it in the forward motion also, but I thought backward recursion is a good idea and it is a lot easier to understand and compute. Thank you very much. We will see you soon in another video. Thanks a lot.